Well, folks, we've dipped our toes into the waters of ionic compounds, but it's time to take the training wheels off. It's time to learn how to write formulas of ionic compounds. We're going to do that with polyatomic ions. We're going to do that with transition metals. No problem. I think you'll have an easy time of it. At least I hope you can. So, basically the idea here is, basic idea. Here's for your notes. Find the symbols, right? You need a periodic table open to do this. I already have mine ready and waiting. And then figure out the subscripts. Right? How many of each element are there in the compound? That's what the subscripts tell us. Okay? So it's pretty simple to do that. What you need to do, and here's kind of the key to figuring out the subscripts, you need to make the positive charges add up to the same as the negative charges. They have to cancel each other out, right? When you touch an ionic compound, like sodium chloride is ionic, that's table salt, you do not get electrocuted, right? It's neutral. So that means that the positive charges in that sodium chloride are balanced out by the negative charges. Sodium is positive, chloride is negative, they balance each other out. So you need to make the plus charges equal the negative charges. And let's take a look at that, okay? So, magnesium oxide. I want to spend most of this video doing examples. First, find the symbol for magnesium. On my periodic table on the right here, it is number 12. It's in group 2, the alkaline earth metals. So I will write down Mg. And I'm going to write down the charge on that ion as a superscript. This is just kind of my scratch paper over here to the right, okay? I'm not writing the formula for the compound yet. That's going to go down here. But you're going to need some side area to work this out. Now we need to find oxide, okay? And oxide is a nonmetal, and it's over here in group 16, and it's O2 negative. Okay, so we have the symbols Mg and O, and now we need to make sure that the charges are going to equal each other. And what we have here is 2 pluses and 2 minuses, so they do equal each other already, which means I only need 1 Mg, because each Mg counts for 2 positives, and I only need 1 oxygen atom, because each oxygen atom counts for 2 negatives. So the formula is MgO. Okay. Side note here, I wish we could do this, but you're not supposed to put the nonmetal first. You always put the cation before the anion, the metal before the nonmetal, okay, the positive before the negative. If we could do it the other way around, then we could make OMG, and wouldn't that be fun? But unfortunately, that's not correct. Let's try another one. Potassium sulfide, okay, find potassium first. Potassium is number 19 in group 1. It's K+, got a 1 plus charge this time. Here's my scratch paper. Then we're going to go find sulfide. Okay. Nonmetal. Always look at the other side. Now sulfide is S2 negative. So here's the first example we have where the charges don't balance out right away. I only have a 1 plus and a 2 negative, right? Well, what you need to do then is you need to add more plus. Okay, so you're going to write down another K+, and now see we have 1 plus, 2 plus, and on the other side we have 2 minus. So total of 2 pluses, total of 2 minuses. This is now balanced out. So we're going to write our symbols K and S, and now you can see that there are 2 potassium ions, so we're going to put a subscript 2 after the K. I don't need to do anything with the S because there's only one of those. so the S just stays alone. And that's our final answer. K2S is the formula for potassium sulfide. Okay. Now you'll notice this is a little different. Maybe you've been thinking, like with covalent we used to be able to use prefixes, right? With covalent it would have said potassium disulfide, and that would have told us, I'm sorry, it would have been dipotassium monosulfide, and that would have told us K2S. But now with ionic we have charges, so we use the charges to figure out how many of each there are, not the prefixes. Okay, let's take it up a notch here. Okay, I've got iron 3 oxide now. This is an example with a transition metal. You know it's a transition metal right away because it's got that Roman numeral in it. Okay, so here is iron 3, and as expected it's Fe3+. So just like before, I'm going to use my little scratch paper area to start out with the cation. The anion is oxide, and oxide is over here, number 8, O2 negative. Now it's interesting, these don't match up. Okay, here is the secret. And in fact, it's worth actually taking some space to write this down. Add ion to the smaller side if needed. Okay, that's what we did in the last example. I only had 1 plus on this potassium, but I had 2 minus over here, right? I went to the smaller side because I needed more plus on that side, so I added another potassium ion on that side. Now here it's the anion, the negative side, that's smaller, so I'm going to do as the rule said. I'm going to add another one of those negative ions to this side, and I'm going to check, does it balance out yet? Well, right now I have 3 plus 2, 4 minus. Nope, we're not balanced out, right? We got 3 pluses and 4 negatives. Well, now the plus side is the smaller side. I only have 3 pluses, but I have 4 negatives, so I better add another plus and see what happens. Okay, well now I'm at 6 pluses and 4 negatives, still not balanced. 4 negatives is less than 6 pluses, so I'm going to add another negative. And oh, look at that. It all just popped out nicely for me. Now I have 3, 6 positives and 2, 4, 6 negatives. 6 negatives, 6 positives. We're good. Now I can finally write down my formula. Okay, Fe is my symbol. There are 2 of them. 1, 2. So Fe subscript 2. Oxygen, there are 1, 2, 3 oxides, so O3. Okay, there's a difference, remember, between the subscripts and the charges. You'll notice in a lot of cases they're reversed. Not always, but usually, right? Fe had the 3 plus charge, but there's only 2 of them. Oxide had the 2 minus charge, but there's 3 of them. So it's like the charge is flipped there. Interesting. Let's try another one. We're on a roll here. Sodium. Group 1, 1 plus, Na plus. Write down that charge. Hydroxide. This one might take you a little longer to find, right? You're going to go digging into the nonmetal corner. You see hydride, oxide, but no hydroxide. Maybe this is a polyatomic ion. Of course it is. And in the middle, lo and behold, these are in alphabetical order. If I go down to the H's, there's hydroxide. And it turns out hydroxide is OH. And it also turns out from this table that there's a little negative symbol there. Do you see that? That means OH is -1. Okay, that's the hydroxide ion. Well, that's pretty handy because sodium is +1 and hydroxide is -1. So that means they're already balanced out. And we just go ahead and write the formula, Na, and then OH for hydroxide, and we're done. Okay, not too bad. Okay, it's basically the same game with the polyatomics. You just got to go look them up in that list. Let's try one. This is about as difficult as they'll ever get right here. Okay, we've got manganese 4 IV. If you don't know the IV, you go find manganese IV. There it is, and then you can see it's Mn4+. And we also have a polyatomic anion here. You can see that right away because it ends with 8, not ide like usual. This is sulfate, not sulfide. Sulfate is in the list in the S's, and you can see sulfate is SO4. And that whole chunk has a 2 negative charge. Okay, that chunk, that clump of atoms is a sulfur with 4 oxygen atoms all together as one. And that whole chunk together has a 2 negative charge. So remember, we need to be looking at the charges right now. Don't let that O4 scare you, okay? It's just a chunk of atoms. Look at the charges. Well, we have 4 positives but only 2 negatives, so we need another negative ion. And let's see if that works out. And of course it does. Now we have 2 4 negatives to balance out the 4 positives. So then our formula, Mn, there's only one of them, so no subscript there. Then I'm going to write SO4, because that's the formula for sulfate. Okay. But now there are 2 sulfate ions here. So we're going to play a little new trick that I need to teach you right now. Okay, when that happens, you throw the whole chunk into parentheses, okay, to show the world, hey, this is a chunk, SO4. And now we're going to put a 2 outside of that parentheses, okay, because there are 2 SO4 anions. And doesn't that look fancy? That formula, that's probably the fanciest formula you've ever written so far. You're going to get good at these, right? It's the same basic idea for all of them. Sometimes the notation looks a little more complicated, but you're just finding symbols and walking them down the line until the charges balance up, and then you're done.